Um, so today we're going to be factoring out a GCF, but in this case we're going to be looking at them when they have a negative leading coefficient. So if you remember, a leading coefficient is the number attached to the variable in the front. Okay, and when I say in the front, that's when the, in this case we're dealing with binomials, when the binomial is in standard form, meaning that its degrees are from greatest to least. Okay, so the front term should have the highest degree. Okay, so remember we had some rules with that. If the leading coefficient is negative, we're going to have to factor out the negative. That's just it. Okay, so the what, why, and how. All right, we're going to learn how to factor out the greatest common factor when the leading coefficient is negative. Why do we do this? Okay, it helps us graph, it helps us find the x-intercept, and it also helps the polynomial itself look easier and more manageable. Okay, how do we know if we would accomplish today's what? Is given a binomial with a negative leading term, we will be able to factor out the greatest common factor. All right, so I'm just going to do 3 examples with you guys. All right, so if you notice, my leading term is -2. That means my leading term is negative. So no matter what, I'm going to at least be able to factor out a -1. But there's going to be more than that. All right, so step number 1 is identifying the GCF. So what is the GCF here? So the GCF, looking at the numbers, 2 and 10, it looks like they both share a 2 because 2 will go into 2 and 10. But because the leading coefficient is negative, we factor out that negative. So I'm going to factor out a -2. And then for the variables, this one has x squared, this one has x. So there's 2 x's here and there's 1 x there. I can take out 1 x from both. That's something common that they both share. All right, so like we did before, I'm going to take out that -2x, and then I'm going to use a set of parentheses here to identify what goes inside in order to make the binomial the same. Okay, so one way of doing it, remember I showed you guys we can take the binomial itself and divide by the GCF. So if I divide by the GCF, I'm dividing by -2x. And if I divide by the GCF, I'm dividing by -2x. So -2 divided by -2 is 1. So I'm just going to say that these reduce to 1. And then x squared divided by x. Well, there's 2 of them here, and I'm taking 1 away, so I'm left with just an x. So that's just an x. And then 10x divided by -2x. Well, the x's are going to cancel out. Well, they'll reduce to 1. And then 10 divided by -2 is -5. Okay, so this is what I'm looking for. Okay, this is the factored version of the original binomial. If I distribute back in, if I was to distribute this -2x back in, I would get -2x squared, and then negative times a negative is a positive, and I would get positive 10x. That's what we started with. So they're the exact same thing. It's just I've made it look different. Okay, I've broken it apart. And another way of looking at it, okay, so we're taking out the GCF of -2x. Okay, so I've got -2x, -2x, and then times something is going to give me -2x squared. And then I've got another -2x, so I could do plus -2x, times something is going to give me 10x. Okay, so negative 2x times x is going to give me negative 2x squared, and negative 2x times negative 5 is going to give me positive 10x. So these share negative 2x, so really it's negative 2x, and then I have this x minus 5 right there. So that's just another way, another method of factoring out the GCF. Okay. All right, so let's look at the second one here. So again, step one is to find the GCF. And again, my leading coefficient is a negative 3. So I'm at least going to factor out a negative. 3 and 2, there's nothing common there. We could say it's 1, but if it was just 1, we wouldn't factor that out. But since there's a negative, we can say negative 1. And then a squared and a. Okay, just like here when it was x squared and x, I was able to take out an x. A squared and a, I'm going to be able to take out an a. So negative 1a, I'm just going to take out a negative a. So I have a negative a, and then I've got my parentheses. So I need to fill that out. I need to fill out these two terms in here that if I distribute back in, I would end up with this original binomial. Okay, so if you can't do it in your head, some of you can, but if you can't, the shortcut is to, or not a shortcut, but the method is to divide each term by the GCF, which is negative a. Okay, and that will give you the two terms in here. So the negatives, negative divided by negative becomes a positive. It's just like multiplying. So I know negative 3 divided by negative 1 is positive 3. So I know there's a 3 here. And then I've got a squared divided by a. Well, this a is going to reduce with one of those. So that leaves me with 1a. Again, the negative divided by a negative becomes a positive. So I know there's a positive 2. And then these a's will reduce out. Okay, so that is the factored version of my original binomial. Okay, and if you want to do it this way too, let's see if I'll get a little bit of room here. You got this negative a, and you're going to multiply by something to get negative 3a squared. And then we have, I don't know, I should put a plus. I'm just going to put another minus a. And then we need to multiply by something to get 2a, or negative 2a. So I've got negative a, and I want to get negative 3a squared. So in order for me to multiply this to get this term of negative 3a squared, I would multiply by 3a. Because negative a times 3a is negative 3a squared. And then I have this negative a, I need to multiply by something in order to get negative 2a. Well, that's just 2. Okay, so if I pull out this negative a, I'm left with what's here because they both share that a. So I have 3a, and then that's a positive 2, so it's 3a plus 2. Okay, just another way of doing it. Okay, I know this is what we've been doing in class. This is sort of new if you guys want to use it. Okay, but if I was doing it, right, I got the negative a, I don't know what's here yet, I just look at it and say, oh, okay, I just multiply by 3a, that will give me negative 3a squared. Or, I don't know what this one is, I have negative a, if I was to distribute back in, I need it to become a positive 2. So notice how my signs change. This was a positive 10, now that's a negative 5. This was a negative 2, now it's a positive 2. Because when you factor out the negative, it changes the sign of both terms. because I'm taking it out from both terms, because I'm factoring it out of that expression. All right, and then here, again, we have a leading coefficient. That's negative, so guaranteed we're going to be able to factor out at least a -1. But again, there'll be more than that here. Okay, so these are both 1, so I know I'm going to take out a negative, maybe a -1. Well, we'll see. Let's look at the variables. So I have 3x's and 2x's. So I can remove 2x's from each. I can't remove 3 from each because this one doesn't have 3. So I'm going to factor out a -x². Okay, so I have my factor in front of the parentheses. And this one should be more logical. You should be able to do it in your head. So I have -x². If I distribute back in, I want a -x³, right? And that should be an x, because an x will give you that x³. And then when I distribute back in, so remember the sign's going to change. So this is going to become a plus. And I already have a -x² here. So it's just going to be a 1. So if I distribute back in, that will give me the -x². Okay, let me erase this. And then again, if you needed to show some work, right, if that was confusing, you just take your terms and you divide by the GCF. So the negatives cancel each other out, right? Because the negative divided by negative is a positive. I have 3 of these and 2 here, so this is going to take 2 away, leaving 1 of them. So that's a positive x. And negative divided by negative is a positive. And then x² divided by x² reduces to 1. So that's why it's x plus 1. And that's why we got it right there. Okay. So hopefully you guys are able to do them with the leading coefficient being negative. I'll give you some practice problems and we'll go from there.